All right, guys, we're going to do day 3 in notes today. So before we start working with exponents and fractions, I just wanted to do a little bit of review from day 1 and 2. So we are going to focus on the negative rule for right now. So from before, when we talked about negative exponents, we said if x has a negative exponent, it doesn't make x negative. The exponent is just simply saying that it's going to be turned into a fraction. So in order to have a positive exponent, we're going to put it under a 1. This also works backwards. If you already have a fraction and your x has a negative exponent, the negative exponent is saying change the position. X should be on top, and that will make your exponent positive. So we're not changing the sign of x, we're changing the position of x. So let's take a look at example 1 and 2 here. So in example 1, we have 7 times x to the power of negative 5. So the exponent here is on the x. So if we were to simplify this, the 7 stays where it is, but x, to make it positive in the exponent, would go toward the bottom. So this would be a simplified version where all the exponents are positive. You'll notice again, it's not negative, it's just in a different position. In example 2, same idea, the 3 and the a already have positive exponents. It's like an invisible 1. So the 3 and the a don't change, but the b at the bottom has a negative exponent, so it needs to change positions. It needs to come up to the top, and this is what our final answer would look like. Now all of these answers have positive exponents and they are simplified. In our next example, example 3, same idea. I'm going to go through and simplify to make sure that all of my exponents are positive. 15 doesn't change. The x has a positive 3. The y has a negative 1, so I'm just going to write the y on the bottom. I'm not going to write the positive 1 here because anytime we have a positive 1, I don't really need to write it. I already know that I have one y at the bottom. Going on to example 4, same idea. I am simplifying here. The 8 is already positive, so it stays the same. The x has a negative exponent, so it's going down below. The y is positive, and the z goes below. So again, the symbol of the overall number doesn't change. Nothing is negative here. The exponent is just telling us that it is in the wrong position. Moving on to example 5, I have to do the power of a power rule first. So that means I'm going to be taking that negative 3 that's on the outside, and I have to multiply it by each of my numbers first. So this is really saying 2 to the power of negative 3, a to the power of positive 6, and b to the power of negative 9. So my final solution is 2 to the 3 on the bottom, a to the 6 on top, and b to the 9 also on the bottom. And that is my final solution. Lastly, in example 6, we've got a negative a to the power negative 3. So again, your exponent does not change the symbol, especially when our negative here is not included in brackets, so it's just going to stay on the outside. So this is negative 1 over a to the power 3. I have one more example here, example 7. This is one where I again have to do a couple of steps first. So when I am doing this, I am going to be matching up the bases. So I have a group of 3's here that I need to simplify. I have a group of a's that I need to simplify, and b doesn't have a partner, so it's just going to stay the same. So first thing I do is I simplify what I've got. Using my power rules, I have 3 negative 2 minus negative 1. That's my quotient rule. Then I have a 2 minus 5, and b is on the bottom. It's just going to stay negative 6. Then what I do is I simplify as best I can. So this is going to be 3 to the power of negative 1, a to the power of negative 3 over b to the power of negative 6. The reason I left the b at the bottom is because it didn't have a partner, so I don't need to simplify it, so it's just going to stay where it is. Now, in this one, all of my exponents are negative, which is a pain, but really all this is telling me is that they're all in the wrong position. So what I need to do is reorder them in the correct position. The b needs to go up to make positive, the 3 needs to go down, and the a needs to go down. So that was a review of what we've been doing in day 1 and 2. Simpler examples, but you get the idea. Today what we're going to focus on is looking at how we can write fractions in exponents as roots. So we know from last unit that when we multiply two roots, we can put them together under one root and multiply the insides. But since I have two x's and this is a square root, because they are partners, this is just going to give me x. So anytime you have a square root of something times itself, you are always going to get whatever was inside. So square root y times square root y will always give you y. You can do it with numbers as well. Square root 2 times square root 2 is just 2. So anytime you have roots, if you multiply them by the root type, you're going to get the number underneath. This also works with cube roots. If I have a cube root, let's say I have cube root of 4 times the cube root of 4 times the cube root of 4. Well, again, using our radical rules that we learned in the last unit, this is the cube root of 4 times 4 times 4. Well, cube root means I'm looking for a group of 3. Here they are, so this just simplifies to 4. So in a square root, we are looking for groups of 2, like that. But in a cube root, we're looking for groups of 3. So if the inside is the same, then you can just right away go ahead and simplify it. Now, exponents are very similar to roots in that they kind of follow the same rule. These are the exponent rules that we talked about this week. When we're looking at roots, they follow the same rules. What we need to understand is the idea that roots are really exponents that are fractions. Exponents that are fractions. And I can show you this by doing that last example. So on my last slide, I had square root of x times square root of x equals just x. Now we know that the exponent on just x is 1. We know that the base here is x. So if I were to write this in exponent form, what I'm saying is x to the power of something times x to the power of something equals x to the power of 1. Now these two somethings are the same. Well, what plus what equals 1? If you think of fractions, this is actually telling me that my something is a half. A square root is represented by a half. So 1/2 plus 1/2 equals 1. So if it followed the exponent rules, this is how I would write it out. So what this tells me is that anytime we see a root, it's actually an exponent written as a fraction. If I have a square root, that means my exponent is 1/2, because remember, square is looking for groups of 2. If I have a cube root, that means my exponent is 1/3. I'm looking for groups of 3. So when we're dealing with roots, we're actually looking at exponents. They're just in fraction form. So in general, our rule for this is that if you have a number to the power of a fraction where you have a 1 on top and some kind of number on the bottom, in this case I'm using the n to represent the number, this means that if you were to rewrite it, this would be the nth root of x. So again, an example, if this is x to the power 1/3, that means what I'm asking for is the third root of x. If I'm looking at x to the power of 1/4, that means I'm looking for the fourth root of x, and so on. So anytime you have a root, it can be written as an exponent where the root is represented by the denominator of a fraction. Let's take a look at an example 8. I'm going to use the idea from yesterday and today and combine them. Example 8 will say, simplify the number 25 to the power of 3/2. So the key here is to recognize that what we are doing here is saying that we want to rewrite this as a root and an exponent. So one thing that we should know is to make 3/2. I can split this into two numbers. I could say this can be written as 3 times 1/2, right? Because the way that we multiply fractions is we put an invisible 1 under the 3. The 3 times 1 gives me a 3. 1 times 2 gives me a 2 on the bottom. So I could rewrite my example as 25 to the power 3 times 1/2. Well, thinking back to our exponent rules, which rule tells us to multiply what we have in our exponents? This is actually power of a power. Power of power. So I could simplify or rewrite this even more. I could say, actually, this could be 25 to the power 3 to the power 1/2. So the inside exponent is telling me to cube it. The outside exponent is telling me that I need to take the square root. So I can rewrite this even more. I could say, okay, this is the square root of 25 to the power 3. And then we simplify. Now, because we also have this rule, so I'm going to do a little sidebar here, side note. We also know that in math, when we're multiplying, the order that you multiply two numbers doesn't matter. So for example, if I say 2 times 4, that is 8. But I can also say 4 times 2, that is also 8. It doesn't actually change how my answer is going to look. So another way that I could rewrite this is 25 to the power of 1/2 times 3. I'm just changing the order that I do my exponents. And so if I follow it that way, that means I have the square root of 25 all to the power 3. Remember, we're looking at this as power of a power, but we're undoing it. We're going to do it backwards. I like this way better because this usually makes the inside number small first, and then I multiply it through. So the square root of 25, I can simplify it to just 5 with the 3 on the outside, and that's going to give me 125 as my final answer. Whereas if I did it this way, I would have to do 25 times 25 times 25 and then square root it, but I wouldn't know what that number would be, so I would have to do the prime factorization, and it'll get a little bit messy. So in general, when you have a fraction where there's a top number and a bottom number, we want to write it this way. So this is what our general rule looks like. We have A over B. The top number is an exponent. The bottom number is a root. You could also write it the other way. That would still be correct, where you do the top number first and then you do the root second. The problem with this is that you'll end up with a really big number on the inside, and then you got to do it on the outside. So I would really prefer you guys use this method. Make the number small first and then do the exponent. All right, let's try some examples here. In example 9, I have 512 to the power of 5 over 3. So again, remember that your top number is your exponent and your bottom number is your root. So I'm going to rewrite this using the first method that I showed at the top of the page. I'm going to say 512. I want to make it a small number first, so I'm going to take the root first. It's a cube root because the bottom number is 3. And then I will put it to the power 5, because 5 is my top number, that's my exponent. You may use your base chart for this. If you look up the number 512, you will find that it is actually 8 cubed. So the cube root of 512 is actually just 8. And then I still have an exponent on the outside, and again I'm going to use my base chart, and that's going to tell me that my final answer here is 32,768. In example 10, I have 16 to the negative 3 over 2. Before you do anything with your fractions and your exponents and whatever, first change the position. Anytime you have a negative exponent, that is telling you that the 16 is in the wrong position. So I'm going to change the position first. This is 1 over 16 to the power of positive 3 over 2. And again, same thing as last time. Your top number is the exponent. Your bottom number is your root. So this is really saying 1 over the square root of 16 to the power 3. And again, we simplify this one step at a time. This is 1 over 4 to the power 3. So simplified all the way is 1 over 64. In my last example, I have 2 numbers, and both of them are to the power of negative 1/2. That means that they are both in the wrong spot. So looking at this could be rewritten as 16 to the negative 1/2 over 81 to the negative 1/2. What this is telling me is that they are in the wrong position. The 16 needs to go down. The 81 needs to go up. So in order to make my exponent positive, I need to put them in the correct positions first. So 81 on top, 16 on the bottom. My exponent is 1, so I don't need to write that. But I have a 2 on the bottom, so that means I have a square root, just a square root in this case. So that means I have square root 81 over square root 16, and I can simplify that to 9 over 4. And that is my final answer. For my last example in this video, I'm going to do a little bit of a challenge problem here. My goal in this question is to simplify as much as I can. So, using my exponent laws, I know that this is going to be 4 to the power of 2 over 5 plus 3 over 4, right? This is the product rule. And in order for me to simplify these exponents here, I'm going to need to do common denominator. So I'm just going to do them on the side here. So common denominator here, I'm just going to call them denom. I'm going to use the number 20 for both of them. Okay, so for the first one, I multiply by 4 to get 8. The second one, I multiply by 5 to get 15. So when I add them together, this is going to give me 23 on top and 20 on the bottom. So what this is saying is, in this question, I'm going to get 4 to the power of 23 over 20. This is telling me my exponent. This is telling me my root. Now, something to note is if you can simplify this to a smaller number, always simplify your fractions. So for example, if I ended up getting 24 over 20, I would want to divide this by 4 to give me 6 over 5, just so I could work with smaller numbers. Your final answer is going to look the same, but always try to simplify. In this case, I cannot simplify. And this is also a case where if I wrote it the way I did my other two, meaning root 20 of 4, all to the power of 23, there is nothing I can do here. I can't simplify it anymore. But if I wrote it as 4 to the power of 23 and then do the 20th root, this would give me some options. I could say, well, I know that 4 to the power of 20 is really saying that I'm going to have 23 fours. 4 times 4 times 4, ... 23 times. And the 20th root is telling me that I am looking for a group of 20. And I am going to get a group of 20. In fact, I'm going to get a group of 23. So that means that I could actually pull out 20 fours to say that the simplification here would be 4, 20th root, and I have 4 fours left over. This would give me the final answer of 4, 20th root of 64. This is the absolute simplest form that we are going to be able to do this one. So in my last examples, it was easier to do the root first because usually the number got smaller and then we did the exponent. But if you have a really big root and there's not enough factors inside, then multiply your exponent first. Get that really big number and then see if you can pull out at least one group so that it looks like this. So we had 23 fours, we pulled out 20 of them, we had 3 left over, So 4 to the power 3 is 64. That's left in our root. It's still a root 20. Don't forget those little details. And we have a 4 in front. So that is all of day 3. Your homework is to complete day 3 for Thursday. And don't forget that we have a quiz tomorrow, and I'm going to include a couple of questions from each of our days, but I'm going to focus more on day 2 and day 3. All right, good luck.